Assalamualaikum to my panel for Bachelor Degree Project 2 presentation. First, Madam Wan Hasrullah binti Wan Hassan as panel 1 and Sir T.S. Muhammad Erdi bin Ayub as panel 2. My name is Ghazi Biwa Muhammad and my Bachelor Degree Project title is Design and Development of Planar Lock Periodic Spiral Antenna for Energy Harvesting. My supervisor is Nurul Halil bin Hashim and my co-supervisor is Dr. UTeM Zaki Hussein. So this is my poster for my Bachelor Degree Project. First, introduction. The study for this project is about RF energy harvesting by using planar lock periodic spiral antenna. The antenna must work at lower cutoff frequency around 300 MHz to 3 GHz. By using CST Studio Suite 2019 software, an antenna is designed and simulated to get the desired result. At the end of this study, the simulation result will be as desired result. First, the return loss S11 must at least negative 10 dB or below. Second, the voltage standing wave ratio VSWR is around 1 to 2. Third, the gain is higher than 3 dBi. And last, the radiation is close to 0. Next is problem statement. There are two problem statements. First is planar lock spiral antenna not work well at lower cutoff frequency range. Second, limited sensitivity on wider bandwidth at lower cutoff frequency. Objective: to design and fabricate planar lock periodic spiral antenna at lower cutoff frequency to achieve better S11, VSWR, bandwidth gain and radiation efficiency. This is my methodology for my bachelor degree project. So start, define the problem statement, which is the antenna not work well at lower cutoff frequency. Determine the specification of the design antenna. I need to calculate for the meter of the antenna. Second is specification, calculation and material selection. By using the specific formula, I need to find the diameter of the antenna and design antenna simulation and result. After I get the parameter by using formula, I need to design the antenna. If the result is not achieved as desired, then I need to repeat the calculation. If the result is desired and achieved, then I can finalize the design antenna. After that, I can fabricate the antenna on PCB board. And so this is my final design for lock periodic spiral antenna. The yellow one is, the orange one is the page, the green one is the substrate, and the red is discrete port. So this is my parameter list. The coil thickness is negative 0.035, the alpha is 0.42, the inner radius for the coil is 1.37, the number of turn coil is 1.8, the angle of increment for the coil is 5, and the coil delta is 120 degrees. So this is my first result, which is return loss or S11. As we know, a good antenna need to have at least at negative 10 dBi. So this antenna would at lower frequency start from 0.5199 GHz. As you can see here, this is the starting point for negative 10 dBi, and then if move on until the end. The second result for the antenna is voltage standing wave ratio or VSWR As we know, a good VSWR value is in between 1 to 2. For this antenna, the VSWR is 2 when the frequency is 0.50983 GHz. Therefore, starting from this point until 3 GHz, the VSWR is maintained in between 1 to 2 value. Therefore, our objective to have a good VSWR is achieved. Next is 3D result for the gain. As we can see, the gain of the antenna is 3.542 dBi. In our objective, we need to achieve a gain higher than 3 dBi. So we can assume that we achieve the objective by having a gain higher than 3 dBi. At the same time, the radiation efficiency show that negative 0.166 dB is close to 0. As we know, antenna radiation efficiency is better when closer to 0. So reference, this is example of the journal that I use for reference for this study. The first journal is from Kapil Ganwa, Jerome this year, 2019. The title of the journal is Modified Log Periodic Spiral Antenna for Multiband RF Energy Harvesting Application. The second journal is from Jasper Tyson, Kajbi Kajobsen, and Corrigan Apple and Sen, 2001. The title of the journal is A Logarithmic Spiral Antenna for 0.4 GHz to 3.8 GHz. So the next is video demonstration to how to design log periodic spiral antenna using CST Studio Suite software. Assalamualaikum. So I will show you how to design the antenna by using CST Studio software. First, new template, RF, antennas, planar, time domain, dimension is in millimeter and frequency is gigahertz. So our minimum frequency is 300 mega or 0.3 giga. Maximum is 3 giga. For monitor, we select all. So finish. For the second step is we go to home, pick micros, construct, coils, planar, log, spiral. So we insert the parameter that we calculate. So this is our first arm. For the second arm, we just copy and paste. We select transform, rotate, copy, z-axis 180. So preview, yes, okay. So this is our page of the antenna. Now we need to do for the substrate. We pick bridge, then enter the dimension. X minimum is negative 100, X max is positive 100, Y minimum is 150. For mass is 150. Z-axis is negative 1.6. So for the material, we go to library, search for FR4, this one, C. So yes, look. So okay. So for the coil, we also need to change the material to copper. So go to library and search for copper anneal. Okay. So for the coil 2, copper. So next is we need to do the pot. For the pot, we use discrete pot. So we pick the face center. First, we need to connect to the first coil. So here this is the surface. Select double click OK. And then the second is at the second coil here. So the surface, yes. Then OK. So we can see here that this is our pot, this is our page, the yellow one, and the white one is our substrate. Okay, like this. So this is our substrate, and this is our page, this is our pot, the right one. So the next is we just need to run the simulation. Apply and start. After the simulation is done, we can check our result. Our first result is S11. So we can see here our S11 is negative 10 dB, around 0.4862 gigahertz. So starting from this point, the S11 is maintained at negative 10 or below until 3 gigahertz. So this is our cutoff frequency. So the objective is achieved because the S11 is maintained at negative 10 and below, start from 0.4892 until 3 GHz, which is at lower frequency. The second result is VSWR. For VSWR, the value is to start from 0.4581 gigahertz. Starting from this point until 3 gigahertz, we can see that the VSWR is maintained in between 2 and 1. Therefore, we can assume that our objective to have a good VSWR, which is 1 to 2, is achieved. The last result is fulfilled at 2.1 gigahertz. So for the gain is 3.682 dB. The objective for the gain is to have gain higher than 3 dB. So the objective of the study to have 3 dB for gain and above is achieved. Furthermore, our radiant efficiency is negative 0.2751 dB, which is close to zero. That means this antenna absorbs more RF energy compared to the energy that the antenna reflects back to the surrounding environment. That's all from me. Thank you.